Hello, everybody. Welcome to the 2022 Open Generation 5G Summit. This year, we've created a summit experience that takes us to a whole new level with content and speakers who will inform and change your understanding of 5G use cases. I'm Ajit Kahaduwe, Managing Director of Incubation and the Chairman of Open Generation. I'm joined today by my co-host who co-hosted with me last year, Leila Ribeiro.
Good morning, everyone. I'm Leila Ribeiro, and I serve as the Technology Director for Open Generation. This year, we have 4 sessions over these 2 days. We will cover uncrewed aircraft vehicles in beyond visual line of sight. We will cover our connected world and the additional other 5G solutions, standards and regulations, and evolving our capabilities with advanced technologies beyond 5G. So together, these sessions will include 12 panels and over 60 speakers. There should be a session of interest for everyone here. Welcome.
So I hope you guys will all enjoy what we're going to have over this morning session. We have a really great plan with some exciting keynotes from Thierry Klein and Paul Challoner, as well as our introduction and opening from Laurie Giandomenico. So we're going to open with Laurie Giandomenico, who's the Vice President and Chief Acceleration Officer of MITRE, who is responsible for all of MITRE Engenuity's initiatives, including Open Generation. Laurie's held a number of executive leader positions at enterprise software and energy industry companies such as Pegasystems, NL, and has operated her own strategy and marketing consulting firm called Rocket Strategy with clients in the Fortune 500 companies. Laurie's also been very instrumental for the vision of Open Generation's creation 2 years ago and is one of the founders of the Open Generation movement with use case innovation at our heart. Please welcome everybody, Laurie Giandomenico.
Thank you, everybody. It's great to be here. Great to be joined by Ajit and Leila. I might be a founder, but this would not happen without the team and without the members and without our government liaisons. So it's great to be here. As we kick off our 3rd summit and close our 2nd year of operations for Open Generation, I want to thank the members, affiliates, government liaisons who have helped to grow the 5G R&D collaborative, obviously. Through the Open Generation Consortium, we've been able to bring together some of the world's most innovative experts, which you're going to hear from some of them today, and advanced telecommunications with a belief that use case-driven innovation will accelerate R&D, create meaningful data that drives standards and regulations, and accelerate 5G innovation for the country. It's really about bringing innovation, standards, and informing policy to all together. The challenges to 5G aren't just app proliferation and device penetration. They're industrial, as we all know, and they're essential to evolving our way of life. Open Generation solves barriers to 5G adoption by bringing industrial players from across the ecosystem together, as you see here, with academia, standards organizations, and government. And that's a really key piece, is to bring industry and government together and to figure out where those missions come together to solve complex challenges through real-world testing. And testing that hasn't been done before on test beds that haven't been created before by such a unified group. This year, we're honored to report that our influence is even broader, as Open Generation was awarded a position as a market representation partner with 3GPP, giving us an opportunity to be a part of the driving force that 3GPP has been and will continue to be throughout the evolution of 5G. I'd like to extend a special thanks to our management committee that has guided the work of this consortium over the last year. You'll hear from many of them today, with keynotes from our core members, as well as other members, partners, and friends included in our panels throughout the 2 days. Since the world wars, telecommunications networks have been prioritized as core infrastructure for national security. After the attacks of September 11, 2001, the push for telecommunications infrastructure became even more important, as we have certainly realized the importance to pandemic preparedness. 5G accentuates that importance because of its value to business operational technology. And in the face of global strategic competition, the race to lead the advancement of telecommunications technology is one that democratic principles must win. Leveraging MITRE's strength in aviation and communications, along with the R&D strength of these leaders and our membership as a whole, our initial open generation focus has been on UAS over 5G. With the UAS market expected to grow over 4 times from 8 billion to 34 billion between 2020 and 2030, and with almost 40% of 865 FAA registered drones in use today being commercial, we know that it has been important work that impacts public safety, infrastructure inspection, and the future of air mobility. We thank these leaders for guiding the building, testing, and documentation priorities for Open Generation this year, as we've collectively sought to solve real-world problems and advance essential technologies. Let's go to the next, because I want to welcome our newest member. Florida Atlantic University spans 110 miles of Southeast Florida with its main campus in Boca Raton, 30,000 students, and 170 degree programs. FAU leads research in transportation and in drone use cases, including studies in the use of quantum technology on a drone for highly secure communications, drone image processing for better and faster disaster response. So welcome to FAU. It's great to have you in the membership and working with us. Now I want to talk a little bit about our 5G aviation ranges, the hard work that's been done over the last year and what we'll continue to be doing into next year. At last year's summit, we announced that we'd be building a 5G aviation range at the FAA designated Oneida County, New York UAS facility managed by New Air. That range, launched in July 2022, has been a primary location for real-world, beyond visual line of sight experimentation. Development of this range demonstrated the work we can do collaboratively with Spectrum from Verizon, network infrastructure from Nokia, and with our founding members. We have also been working with members Northeastern University and Virginia Tech to build test ranges at their facilities. Northeastern's indoor facility is an anechoic chamber that enables us to test at any frequency, and the Virginia Tech test bed enables us to look at advanced millimeter wave use cases. We built a custom 5G drone for advanced experimentation at these 5G ranges, with Qualcomm providing both reference drones and their Flight RB5 5G platform for drones, and UAVs, which combine 5G, AI, and camera features to enhance mapping, asset inspection, film, photography, and more. We couldn't do it without these partners, and I'm so proud of the progress that the teams have made over the last year. Let's talk a little bit about the technical papers that have been published. I just want to draw your attention to it. These have all been published and recorded, and I wanted to mention them to make sure that everybody's gotten the most out of the work that the team's done this year. So key findings from the work this year have been published in 3 technical papers and a summary of findings. So each technical paper represents a core function of Open Generation and delivers data that's essential to advancing the commercial viability of 5G UAS. 5G UAS use cases look in depth at many of the 5G use cases reviewed in this morning's sessions. The architectural framework documentation explores the technology behind our testbed work. The experimentation plan paper looks specifically at command and control of UAS over 5G, an important consideration that Rick Niles will cover in more detail later today. We're looking forward to hearing from you, Rick. And our overview explores the contributions of members in our work as a whole as we accelerate 5G for the country. So make sure to have a look at those. And now I want to talk about our government liaison program, because this wouldn't be possible without both industry and government coming together. And that's really what our consortium represents. While our cross-cutting industry collaboration and real-world R&D are unique aspects of OpenGen, another aspect that makes this collaborative special is our government liaison program and, of course, the agencies that make it up: FAA, FCC, DoD, NASA, NSA, NSF, NIST, and U.S. Air Force. I wanted to mention all of them because it's so important to have these participants at the table. We've been honored to be able to have these leaders join the members and partners to share ideas and priorities in the public interest. All of the meetings have been recorded for the benefit of anyone who would like to listen to them. Our newest sessions include Mr. Arthur Hinneman, representing the FAA's Office of Unmanned Aircraft Systems Integration, Mr. Andy Lacker, the Chief Technologist for Future Airspace Operations, who shares how 5G networks will contribute to what NASA Langley is doing in the area of unmanned aircraft and advanced air mobility. And a unique state offering from Massachusetts Department of Transportation, who recently reviewed a 40-mile beyond visual line of sight waiver and is excited to use uncrewed aircraft systems to monitor their rail networks. Listen and learn more about the 5G drones that will help them to achieve their goals. Throughout this work with government liaisons, our focus is on real-world experimentation, building and testing use cases with operational significance on a network technology specifically built for a connected world. And all of the data we have collected to influence standards, perhaps the thing that's most revolutionary about Open Generation is our ecosystem-wide collaboration. I'm honored to kick off a 2-day event filled with so many thinkers and doers from across the industry to advance telecommunications landscape. Thank you. And now I want to introduce our first speaker. It's so great to be joined by Thierry again. Thierry Klein is the first president of Bell Labs Solutions Research, where he leads fundamental and applied research into new technologies, value chains, business opportunities, and ecosystems beyond Nokia's core portfolio of products and solutions and services. Throughout his career, he's worked on disruptive technologies that reshaped multiple industries. He was the founder and CTO of an internal startup focused on wireless communications for emergency response and disaster recovery. So his commitment to mission is clear from the history and all the great work that he's done. He's also served as a founding vice chair of the board of the 5G Automotive Association and as the chairman of the Technical Committee for Green Touch, a global consortium dedicated to improve network energy efficiency. I haven't even mentioned his work at NASA. I want to thank Thierry for being here. He's a friend and a longtime original founder with us, member with us. It's great to have him here. And I want to turn it over to you, Thierry, for your remarks.
Great. Thank you so much, Laurie. And thank you very much for the very kind introduction. It's such a pleasure to be here. It's such an honor to be part of the Open Gen consortium from the very beginning for the last 3 years, actually, and really appreciate working with you and the team at MITRE, but also all the members of Open Gen. Also want to thank Ajit and Leila for pulling together this incredible agenda for the next couple of days. I'm super excited about the next couple of days and all the presentations that we'll be hearing about, and really want to congratulate them, maybe in advance, but congratulate them on pulling this incredible agenda together. It's just fantastic work, and I'm very honored to be able to be here and the opportunity to share with you some of my thoughts. I want to talk a little bit future back and motivate with the future a little bit what we're doing today and how we're building towards this future. So I titled the keynote a little bit, "The Drones and the Future of the Industrial Metaverse." And of course, I don't want to get into the buzz around Metaverse, but I want to show to you that there's really underlying pragmatic opportunities and technologies that require all the innovation that we're working on to enable a new future. And so what is that future? When we think about can somebody advance the slide, sorry, please? Thank you very much. So what is that new future when we think about the 2030s, which are really just around the corner? We think that the future will really bring together a closer interaction between our human world, which is all of us, our physical world, and our digital world. It will do so in a very dynamic, very real-time way. We, of course, are people. We live in the physical world. We have a digital world present. But what we will see is a closer connection between our physical, digital, and biological world, all of us. We'll see more real-time interactions. We'll see greater level of intelligence, greater level of understanding, greater level of opportunities for improving our lives, improving how we live, work, in the future. And this is really about bringing together physical, digital realities to improve opportunities in efficiency, productivity, and I would say sustainability for our world in the next decade. Now, if this all sounds a little bit metaverse-ish to you, it is, but I don't want to be talking about the hype around metaverse. I want to show you what I mean by metaverse and why we're all actually been working towards creating that future. Maybe not calling it metaverse, but we've all been contributing innovation towards that future. So if you could go to the next slide, please. What is the metaverse really? For me, the metaverse is way more than just consumer VR experiences. The metaverse, in my opinion, has two fundamental components. The first one is physical digital fusion, which is all about creating digital copies, digital representations of our physical world, whether it's a machine, a device, us as people, or an environment, a space, a building, so forth. So really creating digital representations of the physical world with understanding about the physical world, interpretations, increased knowledge that allows us to understand and optimize the physical environment. And then there's the human augmentation part, which is what everybody maybe thinks about from a metaverse perspective. And that's really how we as people consume this physical digital reality. How do we interact? How do we communicate? How do we control this physical digital duality? And so those two things are really foundational to metaverse. And of course, when you think about consumer applications, you will see both of those things. But we think that the metaverse is much more than just VR consumer experiences. That includes certainly that when you think about gaming, shopping, entertainment. But we also believe that there's an enterprise metaverse, which is all about the future of the workforce, which we started to experience with the pandemic over the last 2.5 years. But we also realized that how we work remotely, how we collaborate, is just not satisfactory. It's not fully sufficient. It's not fully immersive. It's not really what we want to do. And that's why we're all eager to go back to work and be in person again, because the remote digital experience are just not sufficient. So the enterprise metaverse will allow new ways of collaboration, co-design, training, and so forth. But then we also think there's a third one, which is the industrial metaverse, which is really about digital twinning of our industrial enterprise environments. How do we optimize production facilities? How do we improve production? How do we design our environments in enterprise and factories and industrial settings in a more efficient way? And how do we improve the productivity and efficiency in the physical industries, augment it with digital capability? So for the rest of my presentation, I want to focus sort of on the physical digital fusion and the industrial side. And then I'll leave the other parts for a subsequent discussion. So if you could go to the next slide, please. What is the use cases that I then have in mind? And you will see this throughout the next couple of days. We have sessions on each one of these to dive a little bit deeper, but I want to just mention the use cases where physical digital fusion, industrial automation, digital twinning is going to be very, very prevalent. And we are now starting to develop the technologies to enable that future. And that includes everything in transportation, logistics, manufacturing, smart agriculture, public safety, digital health, smart cities, all of the use cases. And we have sessions on some of these topics dedicated to these vertical sectors in the next 2 days. So when you go through these presentations today and tomorrow, keep this in mind of how are the technologies that we're building today, how are they enabling this physical digital reality in these new vertical applications? And are we doing the right things from an innovation technology perspective today to build up towards that future? What's the interplay between the different technologies? How do they interact with each other? How do they build new experiences, new solutions on foundational technology that is maybe independent of the specific use case we're talking about and broadly applicable, but nonetheless very foundational for each of the vertical sectors? So if you go to the next slide, please. So I want to talk a little bit about the digital physical fusion in the context of industrial automation. And when we look at an industrial process, I would say whether it's a physical process or a digital process, there's a fundamental paradigm that I call the sense, understand, act paradigm. Anytime you want to optimize a system, again, whether it's a physical or digital system, you need 3 basic characteristics. You need to first collect information. You need to capture the process. You need to capture environment. You need to collect information and data. Once you have that, and you're still in the physical realm at that point, once you have that information, you want to understand what the data means. You want to extract useful information. You want to extract knowledge. You want to extract insights. Sometimes insights that are not visible to you, but nonetheless very meaningful to the process. So that's now we've transitioned from the digital realm from the physical realm into the digital realm. Once we have this information, this insight, this knowledge, we want to make intelligent decisions. We want to improve the state of our process, want to improve an outcome. So we make intelligent decisions. But once that decision is made, it still needs to be acted upon in the physical world to affect the outcome. So we're again transitioning back from the digital world into the physical world. So we see this loop happening with any automated process. And that loop has existed for previous generations of autonomous systems. But what we expect to happen is that the systems where we apply this loop become more and more complex, more and more dynamic, and this loop becomes faster and faster and more real time. So we need to make sure we have the underlying technologies, we have the underlying capabilities, and the underlying network to support that collection of information, understanding, acting, and be able to do this at very large scale, complex systems, multi-party ecosystems that interface to these systems. And then this loop will run much, much faster than we've experienced in the past. I would actually suggest that what you are doing right now is going through this loop. I'm presenting to you today, and you're listening, you're reading the slides, you're listening to me presenting. So you're in the sensing, you're trying to understand what I mean, what I'm saying, and you may ask a question to understand better or get more insights and so forth. So even you yourself right now are going through this loop of sense, understand, act. And we believe that's really foundational, and we need to make sure we develop the key technologies to enable these loops. So if we would just go to the next slide, please. So now I want to talk a little bit about drones. How do drones intersect with this? In the OpenGen consortium, we focus very much on the networking technology and UAS as a first application. We're looking at maybe other vertical sectors and use cases beyond that. When you want to build this loop of sense, understand, act, you need a lot of technologies. It's clear you need artificial intelligence, you need sensors, you need sensing capabilities, you need data systems and so forth. You need a lot of software. But I also think drones and robotics more generally have maybe a unique place in this industrial automation. And why do I think that? If you look at the common characteristics that I described that are independent of specific use cases and are more generally applicable to the different vertical sectors that I mentioned on the previous slide, and you kind of see how drones can map into that. I'm not saying drones are the only way of doing it, but drones have multiple roles to play in this control loop. The first one is we need to collect information. So we need to capture the world around us. And drones are a wonderful platform as a mobile sensor platform. You can fly them anywhere. You can put any sensor on them. You can collect information, whether it's with video cameras, it's with other sensors. You can deploy them indoors. You can deploy them outdoors. So we should think of drones as a mobile sensor platform that allows us to capture the physical world. If we want to create digital copies, digital twins, digital representations of our physical world, we absolutely need to capture the physical world, and drones play a role in that. So they're at the input of the control loop. Then we want to really create these digital copies very fast, dynamic, anywhere, anytime. And as we increase the speed of this control loop, we need to be able to very quickly create this digital representation. And we need to make sure that the digital representation stays in synchronicity with the physical world. So any changes in the physical world is immediately reflected in the digital world. So for that, we need a system that allows us to capture the information anytime, anywhere, very quickly. And drones are a fundamentally scalable platform. You can start with one drone. You can deploy a couple of drones, all the way up to a swarm of drones of hundreds or thousands of drones. So it's a scalable platform. We've shown that we can deploy drones efficiently indoors and outdoors to really provide that scalable solution. Then we want to make intelligent decisions. So we need to have compute capabilities. One way to do that is, of course, to put all the analytics and the intelligence into the cloud, but we can also consider the drones as a compute platform. Right at the edge where the information is gathered, we can provide compute capabilities on the drones. So the drones are not just a sensor platform, they're also a mobile compute platform. And then ultimately, when we make intelligent decisions and we want to affect an outcome in the physical world, the drones are also an actuation platform. They can provide a delivery platform, they can actuate, they can have robotic capabilities to change the physical state of the world. So I think from that perspective, we should think of the drones as quite unique and intersecting multiple of these elements in the control loop. So if we go to the next slide, please. But if we want to use the drones, they're fundamentally mobile. So we really need a very strong, high-performing network to support this ambition of a fast, dynamic control loop in the physical world. And that requires capabilities that we have with 5G right now, but we need to build beyond 5G, going into 5G advanced, and then ultimately going into 6G to really have the capabilities of this industrial metaverse like applications. And there are two characteristics that are really important. One, I would say, is on performance, and the other is on consumability. When we talk about performance, we need a high throughput network, both in the uplink as well as the downlink. The uplink becomes more and more important because we're collecting a lot of information in the physical world. The future will not be about just downloading videos to your phones. The future will also be about uploading a lot of sensor data to the cloud where it's being processed. So high throughput, symmetric throughput in the uplink and downlink is important. Low latency is incredibly important when we're talking about controlling physical devices and machines. We need to go to sub-millisecond or millisecond level latency with tight jitter controls. Otherwise, the physical control loops, motion control, will just not be able to be supported. And then when I talk a little bit about the consumability, this is really important to allow the network to be deployed, optimized, configured in a very intuitive, seamless, automated way. We cannot spend a lot of time to deploy, configure networks if we want to get to that next level of scale and dynamicity in the networks. So a lot of exciting opportunities already exist today in the network. We need to bring these elements together, and that's really the mission of OpenGen, to take the network capabilities, take the drone capabilities, bring them together in test beds, understand the performance that we have right now, and understand the opportunities and the needs for extending the requirements of networks going into the end of this decade and then into the 2030s. So if you go to the next slide, I want to give you one example of how we in Nokia Bell Labs have already been doing this in a very specific example, and how do we bring the physical digital world together. And this is about a technology collaboration that we have between Nokia Bell Labs and Farms, which is one of the global leading vertical farms in the world. And one of the challenges that they face is to monitor an entire vertical farm very efficiently. This is not possible with people that will go to throughout the farm, go up and down on these multi-level towers to inspect plants. So we need an autonomous system to be able to do that. It's also not effective to put cameras everywhere because you really don't want to watch the plants 24/7, but you need to have semi-real-time information about the growth of your plants. So we've developed an indoor drone solution with data analytics to move cameras and sensors around, capture the entire facility, and provide advanced analytics to understand how the network of plants is growing. And of course, that's only possible if you have an indoor high-performing network to manage a fleet of drones. Now, how does this tie into the physical digital reality? I have a short video that I want to show you. So if Billy, if you could go to the video, and while we're playing the video, I will explain to you what you're seeing. There are three videos in this on this picture. If you look at the top left video, that's a third person view of a research facility that we've built here in Murray Hill in New Jersey. This mimics towers that you would see in a vertical farm, and you see a drone flying in this this setup and between the towers, and it's going to scan the towers and capture images while it's flying. So that's really a view of the physical world. The bottom left, you see a view from the camera on the drone. So that's first-person view from the drone itself. And those are the actual images that the drone will capture, send to the cloud for processing. On the right side of the video, you see a digital twin that we've created. So the towers have first been created by just CAD files, but in the future, you can imagine that even the drone would capture these towers and create a digital representation of that. The drone that you see on the right side is placed into this digital twin based on the exact location of the drone in the physical world. So the green line shows the flight path that has been calculated for this autonomous drone, and the purple dots show the actual position of the drone as it's going through this. And you can see how the physical and digital realities are synchronized. And the next step will really be to see how you can place objects and information that you've captured in real time into this digital twin. So there is a structure that's permanent from the towers that's in the digital twin, but then dynamic information can also be augmented and added to the digital twin. And so this can be used for training. This can be used for simulations. This can also be used for real-time monitoring of a farm operator who may not be in the farm, who may be remote, and wants to see the entire operation and then be able to affect it, be able to change maybe the sensors on the drone or change particular scans that would be required for deeper analysis of the farm. So this is just a small example, but I think it's a great example to show the potential of bringing together network technology, robotic drone technologies, as well as intelligent data analytics to create real use cases that have an impact in the real world. So I will stop here, and I'm not sure if we have time for a quick question. If not, I really want to thank you for taking the time to join today, and I hope that you have a great next 2 days with the OpenGen Summit.
Good morning. I'm Rick Niles. In college, feedback control systems was my passion, and the idea of combining AI and 5G in a feedback loop of our complex systems is just really compelling for me. Pilots are often taught to perceive, process, and perform. That's very similar to what Terry talked about. Combining the use of drones and digital twins is also an interesting way to compellingly make a feedback loop. I also liked how we described drones as flying sensors. I've often said that aircraft missions are often fall into two major categories for uncrewed aircraft. It's either sensing or delivering something. But I like the idea of making it part of a feedback loop with computation on board. It's a really interesting vision. So me personally, I've worked at MITRE for 20 years doing aviation work and navigation systems and uncrewed aircraft. I'm currently the chief engineer for the National Airspace Infrastructure Department. I hold a bachelor's degree from USC and a master's from MIT in aerospace engineering. I've been on the drone lead for Open Generation for 2 years. That's been a huge pleasure of mine and an honor. I'm the technical lead also for both New Air and the Virginia tech beds for OpenGen. I'm an airline transport pilot with over 4,000 hours of flight time with privileges in single and multi-engine airplane, helicopter, gyroplane, glider, and remote pilot. I'm also an active flight instructor in both airplane and gyroplane. This morning, we have 3 panel discussions, each related to a beyond visual line of sight use case. These use cases include using drones to perform existing missions currently executed by aircraft and ground vehicles, but also completely new concepts enabled by the use of drones. Each of these panels will discuss how 5G technology will use these use cases to become a reality and how the convergence of these two technologies, 5G and uncrewed aircraft, will create entirely new markets. First of all, I'd like to just level set all of you. Many of you that are involved with unmanned and uncrewed aircraft probably already know this, but I just want to make sure everybody's on the same page in terms of terminology. There's 2 major challenges when you're talking about uncrewed aircraft. That's what we often call C2 and DAA. But C2 is command and control, and what we're referring to when we say that are the commands from the ground to the aircraft and the telemetry from the aircraft to the ground. So I just helped to define that. And then the other major challenge is detect and avoid. So there's a rule that's been there for since the beginning of aviation that vigilance shall be maintained by each person operating an aircraft so as to see and avoid other aircraft. Basically, that means you got to be looking out the window and seeing what's out there. And if you're not on board the aircraft, well, that makes it a little bit of a challenge. At first, you might think that you could just use a camera, but currently that is not considered the same as see and avoid. So you can use ground-based sensors and aircraft-based sensors, a combination of those. And the actual avoidance part of the maneuver can be done on the ground or in the air. But you've got to do both the sensing of where the other traffic is and the avoidance of where the other traffic is. And again, for those not familiar with aviation, while big airliners and most of us have some sort of a transponder or some sort of sensor that tells you that I'm out there, there are plenty of manned aircraft out there that have no electronic signature. They might not even have an electrical system. So you have to avoid them as well. So our first use case is going to be on public safety. There's an obvious priority use case for drones beyond visual line of sight, and that's this public safety. All of you have heard of drones playing critical roles during hurricanes and forest fires. The important safety work performed by these first responders using this technology is constantly compared to the safety risk of performing the flight in the first place. And so my first bullet here, I have that you have to look at the net safety risk of not flying the mission. It could be greater than performing the mission. I actually just experienced this for the first time. I was doing an ILS on Saturday into airport, controlled tower airport, and I was told my approach clearance was canceled because there was a priority drone flight by the police in that area. And so that was a first for me, that they canceled a crewed aircraft clearance for a priority police mission, but it made sense. There was a police mission and I was out there with a student just doing some practice. So these missions often replace existing helicopter and ground vehicle missions. Think about replacing a helicopter or replacing the deployment of a police car to the local area. And one of the things that makes it a compelling use case for an early adopter is that it involves disciplined, trained, and trusted public operators. This is not opening it up to the general public. These are people that are going to be trained and know what they're doing. Finally, another little twist on it I would mention is that federal agencies each have the authority to issue their own airworthiness certificates. So the FBI and other federal agencies have issued their own airworthiness. The Department of Defense does it all the time, for example. So this is a use case in which everything necessarily doesn't have to go through one agency. That talk will be led by Charles Werner of Drone Responders, and I'm looking forward to it. It'll happen right after I finish here. So the second use case by Browan Morgan will talk about UAS infrastructure inspection. That's actually something that's happening quite a bit now. There's a lot of operators out there that are currently doing roof inspection by use of drones. So they, instead of climbing up on top of your roof, if you have a dangerous or very steep roof, they might fly a drone up there. And in fact, they might actually be able to get better imagery of the condition of your roof rather than climbing up there. And but a lot of those missions are limited to within line of sight, as we say it. So to be able to go beyond line of sight is what the discussion will be about. And they often fly over sections of the operator's own property. So if you think about power lines, pipelines, railroad tracks, or a tower inspection, bridge inspection, any of those sort of things, that's generally over the property owner's property. And so it's less of a getting permission to fly in that area because the particular operator is the owner of the property. A lot of these occur in very remote areas as well. So there's less risk to the public of something falling on you or some side effect. And they're often protected by the infrastructure itself. If you imagine if you're flying under a bridge or really close to a tower, there's not likely to be crewed aircraft right in that vicinity. So that kind of helps the safety case. So they would greatly benefit for the BV loss, because if you think about the power lines or the pipelines, you need to go well beyond line of sight. You need to go long distances to inspect a lot of area quickly. And so BV loss is an obvious benefit for them. So low altitude makes a really good match for cellular, in that, as many of you know, as you go higher in altitude, you get a lot of interference from your other towers in the area. Whereas if you remain very low where this infrastructure is, you get a really good signal. So this is why we think this is a really great use case for combining a useful function for uncrewed aircraft with 5G technology. And I look forward to that talk. And the last talk will be about advanced air mobility. Now this, while the first responders was the obvious first use case, advanced air mobility is really all the way on the cutting edge. It involves a lot of challenges, and but it really promises kind of the Jetson vision of what we dreamt of as a kid, of personal air travel over short distances. In the past, it was called urban air mobility, or UAM, if you've heard that term. So AAM is kind of evolved from UAM. And it's the idea of moving people and packages relatively short distances on demand very quickly. So you can kind of think of it as very similar in mission to a small helicopter. You're moving 1 to 4 people. Some of them talk about moving critical packages as well. And you're flying at or below about 2,000 feet above the ground. So you're not flying really up high and interfering with commercial air traffic. The goal, though, of these missions is to have a very high volume with lots of new vertiports. So there's all sorts of different places throughout the city to land. And this concept usually involves a certified aircraft. So it's on a little longer time frame, where you have a completely certified aircraft. You're not going with some sort of experimental small drone concept. And it also would require that you fly beyond line of sight over people. And that's another big challenge, that you have to make sure that the risk to people is minimized. And finally, another tenet of it is it often involves electric VTOL, or electric aircraft with vertical takeoff and landing capabilities. So Andy Latcher, a good friend of mine, is going to be leading that one, and I look forward to hearing the discussion amongst that group. Thanks for your time. Oh, and obviously, we're going to the first talk, which is on safety use case by Charles Warner. So welcome, Charles.